Hello. Hello.
Hi, Suresh.
Yeah, Jan. Good morning. Yeah, fine, Jan. How are you?
Long time. Yeah.
Yeah.
So you're free for the next 2 days? We'll finish.
Sorry, Jan.
Are you free for the next 2 days? We'll try to finish it off.
Yeah, sure, Jan.
I thought you were busy, so you didn't ping me. So
Yeah. 2 days back,
got
I
too
have
busy.
went to. Yeah. 2 days back, I went to Kolkata. Yesterday
Okay.
night only.
Okay.
Yeah.
So, we covered while and if statements, right?
Yeah, Jan.
And store procedures as well. So we are not done with functions, right?
Yeah.
Okay.
Last class here, you have told we have to start with index.
Okay.
Yeah.
Index functions, indexes are pending, right?
Yeah.
Okay. We'll finish up index and we go to indexes. Okay.
Yeah, sure, Zion.
Are you able to see SQL Server?
Yeah, yes.
So, function, just like stored procedures,
Okay.
functions are also a group of SQL statements. Okay. Just like
Okay.
in stored procedures, we will be using some statements, right? So
Yeah.
in stored procedures, we can use some insert statements, update statements, or delete statements, right?
Yeah.
Just like that, inside the functions also, we can use some group of SQL statements. But the difference between those stored procedures and functions is functions must return a value. Okay. But
Okay.
stored procedures can return a value or they may not return a value.
They may not be written error.
Yeah, the may or may not return a value stored
Yeah,
procedures.
yeah.
Because in stored procedures, let's say we can we can put some 10 update statements in the stored procedures and just create the stored procedure that would run.
Yeah.
So with the update statements, we will not get any result, or we will that will not return any value. Whenever you are running the update statements, it will not return any kind of value, right?
Yeah, Zion.
Yeah. But the functions, in the case of functions, so whatever the statements you write, you can write, but at the end, the function should return a value. Okay.
Okay.
Yeah.
Yeah, yeah. Got it.
So we have seen this aggregate functions, string functions, all those things, right?
Yeah, yeah.
We have seen substrings, left off, right off, ltrim, martrim. So all those are all functions only. Okay. But
Okay.
they are, by default functions, yeah, coming with the SQL. Okay.
Okay.
So even for those functions, whenever you execute any aggregate function or mathematical function or string function, anything, if you are executing any function, you are getting some result out of it. Okay.
Okay.
So without the result, the functions are not there, right?
Yeah, Zion.
So whatever function you use, whether it is a system function or user defined function, so it should return a value. Okay.
Got it.
Okay. So inside the functions also we have two types of functions. So one is scalar valued function and another one is table valued
Table value
function.
function.
Scalar valued function is it will just return one single value. Okay. Let's
Okay.
say you are creating a function to add just two numbers. Let's say you are adding 100 plus 100. Okay. So the output would be only one number, 200. Okay. Just
Got
like
it.
that,
Yeah.
any single value, it will return only one single value. Okay.
Okay.
Okay. Whenever a function is returning a single value, then we call that as a scalar valued function. But whenever a function is returning a table kind of thing, okay, a complete
Okay.
table or one single row, so then we call it as a table valued function. Okay. So whether it might be one row or more rows, that doesn't matter. If it is returning more than one single value, then we call it as a table valued
Table
function.
value. Got it. Got it.
You can see the function syntax right here. Hello, are you able to see the
Yeah, yeah.
syntax for function?
Yeah, yeah, Zion.
So if you see here, we are selecting from selecting sum of salary from employees. So what is the highest number here you are getting? Hello. 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 Hello.
Hello.
Yeah, can you hear me?
Yeah, Zion.
So are you able to see the function definition, right?
No,
You're
Zion.
still seeing the SQL server, right?
Yeah.
Let's discuss about square value function. So right, use create and keyword function here. Okay. So the best practice is that so whenever you're writing any function name, use UDF or FN before the function name. Okay. So that way you will be able to determine whether it is a function or a view or a table or a stored procedure. Okay. So just
Got it.
like that, UDF or FN for stored procedures, you can use USP, user stored procedure, and for views, you can write something called VW underscore. Okay.
Yeah, got it.
So I'm just giving a name for this. We are discussing about scalar valid function. After the name, you have to give two brackets here. Okay.
Got it,
And
Zion.
so after the create function, create keyword, you have to give the data type of the output value. So before writing so whenever you're writing the function, you would know what should come out of that function, right? Let's say
Yeah.
you are doing some mathematical functions, the output would be something like a number, right?
Yeah.
So you know the data type of that number, you know the data type of that returned value. So in the before itself, while creating the data function itself, you have to specify what type of data type it is this function is going to return. Okay.
Okay.
So I'll just give returns int. That means it will return integer data type value. Okay. As begin. Now let's try the code. So I'm just declaring some variables here. So we will take department number here. Just a minute. Hello.
Yeah, Zion.
Darshan. So this is our function. This is the code inside our function. So what we are doing here, we are just declaring two variables. I'm setting one of the giving input for one of the variable,
Okay.
and this out this variable that variable I'm using in the where condition. And for this variable, I'm assigning the value at the rate sum of select. Okay. So for
Got it.
the given department number, we are getting the maximum of salary. Okay, right?
Okay. Yeah.
So let's create this function. So how to execute that is you have to use select statement. For stored procedures, what were we using? For execute and stored procedures, what is the keyword we were using?
Begin end.
No, we were using exec. That is the command which we were using to execute the stored procedure. Okay.
Got it, Zion.
And for functions, we have to use select here. Okay.
Okay.
Select your function name. Whatever is the function, you have to print that. This is how you can use them. But the thing is, every function should have open and closed parenthesis after that mean. Okay.
Got it, Zion.
So whenever you see this kind of brackets, you should know that it is a function. Okay.
Function. Yes, Zion.
Is not recognized function. So what is happening is it is not getting executed without the schema name. So I have just given the schema name before that.
Yeah.
See, whenever I execute this command, it is giving me the maximum salary of employee in the department number 10. Okay. So here now let's say if you want to see the maximum salary of employees in department number 20, what you should do? You should alter this function and you should change the value to 20 and then again execute the command, right? So without doing that, so what we can do is we can use the same scalar valued function with a parameter. Now, if you see this valued scalar valued function is without the parameter. Okay.
Yeah.
Now we can use the same valued function with parameter. Okay.
Got it, Zion.
Let's see that. So that every time you want to change the input value, you don't have to alter the function, right?
Yeah.
Right. Every time the next case is if you want to see the maximum salary from department number 20, you have to alter the function. You have to modify the function every time,
Okay.
right?
Yeah.
So without that, if you use a parameter, so you can just whatever the value you want, you can just pass it to the function. So that would be without altering the function, you can use. Let's see that. Okay. So if you see here we can declare only one variable. So the variable which we so this department number variable, we are using it as a input variable. So instead of writing it in the code, so we can write it at the parameter level. Okay, this
Okay.
variable. So if we are using it inside the code, it is a variable. If we are using it while creating the function or supervisor, it is called a parameter. Okay. Instead of using it as a variable inside the code, so we will use it as a parameter to the function. Okay.
Got it, yeah.
We will declare that here. DEPT number. This data type. So, and if you observe clearly, so for the variables or for the parameters, there is no difference actually. So both are changing only. They can change the values, but it's just that if you are using it inside the code, it is called a variable. If you are using it while creating the functions or supervisor, it is called a parameter. Okay,
Got it, yeah.
clear? And we
Yeah.
will copy the same statement. Should have taken an exception. The name difference. Okay. See how we can create that table here. Okay.
Okay.
Number 8.
Some artist trying to you would SL up particular artist.
This means syntax here. Just a minute. It's not working without the say what the schema name. The confusion without the schema name, it is not getting created. So this is our function with the parameters. Okay. So here we are using the department number as an input variable. So in the without parameter function, we have declared that inside the code and we are passing the value directly. Okay. But
Okay.
here we are using the department number variable as a parameter, and we while running the function, we have to pass the value from that.
Here integer is a variable, right?
What increases?
That one. At department number, yeah, integer.
Yeah, int is a data type.
Got it, yeah.
Department. This is the department number is a parameter name, and it is the int is the data type of that parameter.
Got it, yeah.
Okay. So I'll show you dbt. So db. So right now, what is the data type of the for input parameter?
Or department number.
No, I'm asking the data type. What is the
Integer.
data type of for integer, right? So let's try passing and string for that. Okay.
Yeah.
So it is a string. It is an varchar data type, right?
Yes. Yeah.
So what is it saying? Conversion failed from
Convert
to data type int. So it is trying to convert this string to integer data type. That means it is looking for an integer data type value. So we have to pass only integer.
Integer, yeah.
Okay. So
Yes,
now I'm passing an integer. So you get the value. So what does that mean? So in the 20 department number, so the maximum salary is 1,000. So we can change the value. We can see for all the whatever the departments are available, we can see for everything. Okay.
Yeah. Got it, sir.
Clear? So this is about function with parameter and without parameter. Okay.
Yes, yeah.
Now let's take a look at table valued functions. So here in the scale, we have to write the what is the data type of the output value, right? So after writing the create function, so if you see here, we are using return int. That means this function will return a value of integer data type. But in table valued function, so here also we should give the data type of the returning value. But here we are not getting only one value to determine the return. We are getting the entire table or the entire row, right? So for that reason, so we have a new data type called table.
Okay.
So we have to use that. So we have to give returns and the name for the output variable @tbl. Any name you can give, okay?
Yes, yeah.
And its data type. So what is the data type now? The data type now is table.
Okay.
Okay. So it is not the name now. In this case, this table is not a name. This is a data type, just like integer, varchar, float, decimal. So the table is also a data type in this case. Okay.
Got it, sir.
And for the table, you have to specify the columns inside the table. For every table, you have some values also, right?
Yeah.
So you have to give the column names as well as the data types for those columns.
Got it.
Okay. number, integer. Right. So just like while creating the table, you will be giving the column names and the data types. No? Just like that, we have to specify everything. We have to give the table name and its data type and the columns inside the table and the data types for those columns as well. Okay.
Yes, yeah.
Now as begin, and now we have to write it insert into. So then write any query. So insert into and that will be here. So out. From here. You can just write return. You don't have to specify the name here. You can just
Yeah.
return. And so for executing this table value function, we should use select star from, just like how we write the how we query the table. Thus, in the same way, we have to query this table valued function also. Because it is a table, right? We have to use select star. But for the scalar valued function, we were just using select, right? For the table valued function, you should write select star from. What we are doing here in this function is we are just returning the employee name and employee salary for a particular department number.
Okay.
So that particular department number is hard coded. That means we have manually given the value. It is not dynamic as in with the whenever you're using this kind of parameter, it is kind of dynamic. Dynamic means while during the execution of something, it can change the value according to the input, right? But these functions cannot change their value. So if you have to change the output of that, you have to change the department number here. So which can be done only while modifying the function, right? So for you, so you can do one thing is as a task. So the same function, the same table valued function, you can create as a parametered one, as a with parameter. Okay. Instead of hard coding this 10 here, create a parameter here itself. Okay. Create a parameter here and pass that value here. Just like how we did for the scalar valued function with parameter. The same way you create one thing for the table valued function also. Okay, so that you don't have to hard code the value inside the function. Okay.
Got it, sir.
So this is about functions. One is table valued function, another one is scalar valued function with and without parameters.
Yes.
Talk about index now. Okay. Let's talk about indexes. So indexes are also nothing but objects in SQL Server, just like your tables or any views or any stored procedure. They are also just an object, kind of objects in the SQL Server. Okay. So the main performance, the main function, the main function of the indexes are to enhance the performance of the query. Okay. Okay. So let's say a table is having some data of about 1 million records. Okay. So to join that table with another table, or if we have to query that, we have to filter out some data on that table. Okay. So because of that huge volume, so it might take some time to get the results. So whenever you are using some where condition, or you are joining this table with some other table, okay. So to be able to get the results from this table will take some time. Okay. So that depends on the column which you are selecting for filtering, and column which you are selecting for the joining condition. Okay. Let's say in our same employee table itself. So this is our small data, right? So we just have some 16 records here. Let's say in this table itself, we have some 10 lakh employee details. Okay. 1 million records of employees. Now, so if you want to see the employees who are having, whose IDs are more than 10,000, okay, whose employee number starts from more than 10,000, and in between some 50,000. Okay.
Okay.
So you want the employee details whose employee number is in between 10,000 to 50,000. So that is the filter condition, right?
Yeah.
So how do we write the query here? So let's start from employee, where employee number between 10,000 and 50,000, right? So that is the query we will write.
Yeah.
So what is the column we are using for filtering the data? Employee number.
Oh, employee number. Yeah.
Right. So based on that employee number column, we are filtering out the data. So let's say this employee number doesn't have the index. It is just a normal table, normal column without an index. Okay. So the numbers are all scattered here. So are they in order here? So they are all scattered, right?
Yeah.
I mean, they are jumbled. So the last number might be in the beginning. So they are just random numbers. They are not in the sorting order, right? So whenever the column data or the table data is in a random order, so it will take some time for the system to search the required values. So how the system will search? So first it will take the first record, and then it will say it will evaluate the condition whether it is between 10,000 and 10K or 50K, and then if it condition satisfies, it will take the value, and again it will go to the next value, and again it has to do the evaluation, and again check whether it is true or false, and again the third condition. So likewise, it has to perform all this operation for 10 lakh records, right? For all the 10 lakh records. So it has to go one by one, right? One by one it has to go, and again it has to evaluate the condition. So for this process, it might take time if the employee numbers are in random order. Okay. But let's say the data inside the employee number column is in sorted order. Let's say it is in some ascending order, right?
Yeah.
So let's say it is in some ascending order from 1 to 10 lakh. Okay. So now what the system will do, if it system can eliminate the first 5 lakh records. Okay. I mean the next the
Yeah.
last 5 lakh records it can directly eliminate. No need to check them at all, right? Because in the last 5 lakh
Yes,
we will not have our 10,000 to 50,000, right? So in the remaining 5 lakh also it can eliminate the last 4 lakh, right? It doesn't have to check the last 4 lakh records. So because 10,000 and 50,000 doesn't fall under that. Okay, it will just check 10,000 and 50,000 will fall under that or not. So it will not fall under the last 4 lakh also. It will just eliminate them. And again, it will in the remaining 1 lakh also, it will just check for the whether this 10,000 15K will fall in the 50. Are they above 50,000 or less than 50,000? So our case is less than 50,000. So it will eliminate the next 50 also. So in that remaining 50,000, it will now filter the data. So now how many records our SQL has to scan? It has to scan only some 50,000 records. Right?
Yes, yeah.
So the number of records it is scanning is reduced. That means the time taken for the system to give us the result will be very less. So that means the performance of the SQL will be very high.
Got
Right?
it. Got it. Yeah.
Is it clear?
Yeah. Yes, yeah. Clear.
Yeah. So now you understand. So when the sorting order is in random order, it will take time. When the sorting order is in any order, any ascending or descending order, the time taken will be very less. Right? So to be able to store the data in some sorting order, we would require indexes. Okay. So let's say now I want to filter the data on employee number, right? I can create an index on top of the employee number column. Okay. So whenever I create an index on top of the employee number column, so automatically the data will be stored. The data will be stored in sorted order. Okay. So while storing the data in the table itself, the data will be stored in sorting order.
Yeah.
And whenever you query the data, so let's say you have some 1 lakh records, right? Whenever you say some top 200, so it will display the recordings in the order, not like this. Okay. Not just random numbers. It will display some top 200 records in an order. Okay.
Yes, yeah.
So that's where the indexes helps you in increasing the query performance. Okay. Is it clear?
Yeah. Yes, yeah.
Yeah. And so one more thing is based on the type of sorting you're required. I mean, so whatever the sorting order is inside the table, that has also to be stored, right? The sorting order should be stored inside the system. So based on that sorting order storage, so we have two types of indexes. One is clustered index and another one is non-clustered index. Okay.
Yeah.
So let's talk about clustered index first. So in clustered index, what happens is, so whenever you create a index on a particular column, so whilst inside the table itself, this data will be stored in a sorted order. Okay. Now let's say we have this employee table, right? So we have inserted some 10 records. So so first you have inserted some employee number 1. And the next employee you insert is some 10,000, and the next employee you insert is some 13,000, and the next employee you insert is from 7,000, and the next employee you insert is again 8,000, and the next employee you insert is some 10, right? So we are not inserting the data in a sorting order, right? While inserting the data, we are inserting some random numbers, right?
Yeah.
But in the cluster case index, even though we are inserting the data in a random order, in the SQL server, the data will be stored in a sorted order.
Got it. Yeah.
While storing the data itself, the data will be stored in a sorted order. Even though you are inserting some random numbers, directly it will automatically sort the table itself. Okay.
Got it. Yeah.
So that's what clustered index will do. Okay.
Okay.
So it will directly sort the table while storing the data. Okay. And what does non-clustered index do is, so it will not store the data in the sorted order in the table itself. So it will store, so let's say, in whatever the order we have discussed, right? 1, 10,000, 13,000, 7, 8, 6, right? In the same order, the table, the data will be stored inside the table. It will not be in sorted order. Okay.
Yes,
In
yeah.
clustered index. In clustered index, in whatever the order we insert the data, in that same order, the data will be stored in the table. Okay. But
Yeah.
the sorted order of that column will be stored somewhere else, which is virtually, okay, which we don't see, which we cannot see. Okay. So right now, if you see the table in the SQL server, so it's not in sorted order, it is just some random numbers. Okay.
Yes, yeah.
Whenever the cluster index is applied on the employee number column, you will see the sorted order here also. Whenever you query the table, you will see the sorted order here. But in the class non-clustered index, that is not the case. You will not see the sorted order here in the table. Okay, because the data is not stored in the sorted order. But
yeah,
for the same column, whatever is the sorted order, that sorted order sequence will be stored somewhere else. The sequence of the sorted order will be stored somewhere else.
Okay.
Okay. Clear?
Yes, yeah.
Now, that virtual storage, that sorted order and this table are connected with some keys. Okay. So now every value inside this table, these random numbers inside this table will have a key. Okay.
Okay.
Will have a key. So in the virtual storage, along with the sorted order, so for this employee number value, so the key will also be stored along with this number. Okay.
Okay.
So whenever you apply some filters on the non-clustered index column, so it will directly refer to that virtual sorted order. Okay. It will not search in this table. It will search in that virtual sorted order. Okay. And from that sorted order, it will get the keys for these values. Okay. Whatever the keys associated with value, it will fetch the keys from that virtual sorted order. Okay.
Yes, yeah.
And those keys will be displayed to you. And based on those keys, the values will be displayed to you. Okay. So are you getting confused with the cluster and non-clustered? You're clear.
Little bit confused, but it will clear.
So let me explain you one more time. So we are talking about clustered index now. Okay. So whenever you are applying clustered index on this column, employee number, so while storing the data itself, while inserting the data into this table itself, the data will be stored in a sorted order. Okay. So even though if you insert some random numbers, okay, but while storing the data inside the table, that will be stored in a sorted order. Okay.
But
So let's say you are inserting some random numbers. Okay. So these are all the employee numbers I am inserting. Okay.
Yeah.
So I'm inserting the data in some random order. Okay. I'm not inserting the data in order.
Okay. Yeah.
But while the system, while storing the data inside this table, it will store that in sorted order, in some ascending order. Let's see. Let's keep it as ascending. It will store the data in ascending order. How does it store it? So first it will store 2, and again 30. Okay.
Yeah.
20, 30, 50,
100,
100, 190,
255.
250, like this. Okay. So the data will be stored in this order. Okay, clear?
Yeah, got it, yeah.
In the clustered index. So
Okay.
inside
In
the
non
table, inside the table itself, the data will be sorted. Okay.
got it.
So whenever you query the table, select staff and employee, you will not see this order. You will not see this order. You will see this order. Okay.
Got it, sir.
Here, this is our clustered index. And
Yeah.
coming to non-clustered index, what happens is, so the data will be stored in the table in this order itself. Okay.
Whatever we are given, that will take.
So how in whatever the order we are inserting the data, in the same order, the data will be stored inside the table. Okay.
Got it. Got it.
But the sorted order of that column. So this is the sorted order, right? This is unsorted order. This is sorted order, right?
Yeah.
So the sorted order of the table will be stored somewhere else in the virtual table. Okay.
Okay.
So this sorted order will be stored somewhere else in the virtual table.
Okay. But not in the given table, right?
Not in the actual physical table. Okay.
Okay. But it will save in the virtual table.
Yeah. But the sorted order will be stored in a virtual table along with the keys for every value. Okay. Along with the sorting order. Okay. We have the keys, right?
Yeah.
Those
Yeah.
keys are stored there in the virtual table. I mean, some virtual place, virtual storage. Okay. Clear?
Yeah. Got it. Yeah. How we can say that it is invisible or?
No, you cannot see that. We
Got
cannot
it.
see that. Okay.
Okay.
It's a
But
kind of virtual one. Yeah, it will exist. Whenever you create a non-clustered index, it will exist in the system, but you cannot see that.
Got it. Got it.
Okay. Now, what happens is whenever you query the data from a non-clustered index table, so it will directly go to that virtual sorting order and fetch the keys for these values. Okay.
Okay.
And those whatever the values are associated with those keys, it will display us. Okay.
Got it.
Clear?
Yeah.
So this is just a basic difference between clustered and non-clustered indexes. Okay.
Yes. Yeah.
So this is how the sorting order works in both of them. Okay.
Yes. Yeah. Got it.
And one more difference is, so in the clustered index will be created automatically
Okay.
when primary key is created. So we have discussed about the primary keys, foreign keys, right?
Yeah. Yeah.
Okay. So whenever you create a primary key on top of a column, so the clustered index will automatically be created. Okay. The clustered index will automatically be created. Clear?
Yes. Yeah.
But if you don't have a primary key, you can manually create the clustered index also. Okay.
Yeah.
When you don't have a primary key, you can manually create the clustered index. Okay.
Yeah. Yeah.
But the non-clustered index you have to create manually every time. Okay. So there is one other key where if you create that, this will create it is unique key. Automatically created when unique key is created.
Okay.
So we discussed about unique key also, right?
Yes. Yeah.
Yeah. So when primary key is created, clustered index will be created automatically. When unique key is created, non-clustered index will be created automatically. Okay.
Got it. Yeah.
So one more difference is you can create only one clustered index for a table.
Okay.
You can create only one clustered index for a table. only on any one of the column. If you have some 200 columns, you can create only on one column. Okay,
Got it.
but you can create up to 999 non-clustered indexes.
Okay.
Okay, you can create up to 999 non-clustered indexes. Is it clear?
Yes, yeah. Only one column will be created in clustered index. In non-clustered
No.
index, yet
On top of only one column, we can create clustered index. So you should say like this: on top of only one
yeah.
column, we can create clustered index. So let me quickly give you quick differences. Okay, in clustered index, whatever the physical order of the table will be equal to the logical order, right? I mean the sorted order, I can say, not logical order, the sorted order. The physical order of the table is equal to the sorted order, right? So in the table
Yes.
itself, the data will be sorted, right? But in the non-clustered index, the physical order will not be equal to the sorted order. The sorted order will be stored somewhere else. Okay.
Yeah.
So both the order is not same. But in clustered index, the physical order and the sorted order will be same. Okay.
Yes, yeah.
And we can create only one clustered index per table, and we can create up to 999 clustered index, non-clustered index for a table. Okay. And if you create a primary key, the clustered index will be created automatically. And when you create a unique key, non-clustered index will be created
automatically. Yeah.
Yes. Okay. So usually most of the times we don't have to create the indexes. Most of the times we try to create keys along with them. These indexes will come. Okay.
Got it.
The syntax for creating the non-clustered index will be just create you have to give the index name here.
Okay.
And you have to give on what column you want to create. Okay.
Got it.
Create clustered index. And you have to give the index name for the index. Okay.
Okay.
This you can give anything. On, you have to give some employee, let's say an employee table, EMP table, and in the brackets you should give the column name. Okay.
Yeah.
So what does that mean? On this column in this table, we are going to create this index.
Next name. Yeah.
Clear?
Yes, yeah.
The same way for the non-clustered index. Instead of using the clustered index there, you can write just non-clustered index.
Non-clustered. Yes, yeah.
That's it. Okay.
Yes, yeah. Got it.
Both would be same. And if you see here, if you want to create the non-clustered index on two columns in the same table, you can just give another name also, another column name like this. But in the clustered index, you can give only one column name. But in the non-clustered index, you can create on multiple columns. Okay.
Yeah, yeah.
Like I said, you can create some multiple clustered indexes, right? So multiple clustered indexes, and you can use on multiple columns. So you can specify multiple column names also here. Okay.
Yes, yeah. Got it.
So this is about indexes. So fine. So we have one more topic, so which is called triggers. Okay.
Okay.
So with that, we will finish it off. So if you have any doubts or if you need any clarifications, okay, we'll just revise it tomorrow and we will finish it. Okay.
Yeah, sorry. Yeah. Anjan, please send the SQL app link.
The download one, right?
Yeah.
Earlier it was straightforward, now they have changed everything, so like we need to. So I've bring you. So if you ping you a link, okay. So if you
Yeah.
go to that link, you will have three options. One is SQL Server on Azure, SQL Server at the edge, SQL Server on premises. Select the on premises one, okay,
Okay.
and you can select the Express Edition.
Express edition. Okay.
Express Edition, and on premises, okay.
Okay. Clear.
Clear.
Yeah.
That's it. Yeah. So tomorrow we will wind up with triggers, and if you have any doubts, okay, we will discuss tomorrow.
Yes. Yeah.
Clear.
Yes.
Okay. Fine. Thank you.
Yes. Yeah. Thank you. Bye.